Okay, so today we're going to cover Chapter 2, Section 5, and today we're going to learn how to prove statements about segments and angles. So what we're going to be doing when we write our proofs, which we already saw in the algebra proofs, we're going to be writing all of our proofs in the two-column format. And a proof is just a logical argument that shows a statement is true. There's various forms of proofs. You're going to see flowchart proofs, paragraph proofs, or the two-column format, which is what we will use. Now, anytime you're looking for additional practice problems, if you go to your online resources and you go to your textbook, if you find a question where the instructions say write it as a paragraph proof, you could just take the sentences out of the paragraph and put them into a two-column format. Same thing with the flow chart. The flow chart, it's just going to be a bunch of boxes and arrows, but again, you can organize it into a two-column format if you're looking for additional practice problems. But we will always only use this format where you're going to have a column for statements and a column for reasons. Your statements are going to be the given information, and then from that given, it'll be either the result of applying a known property or a fact, or maybe even the solving process if it's algebra. And then the reasons are going to be explanations for each statement. And those reasons are going to be your definitions, your properties, your postulates, your theorems. And we're going to see that on the next slide. Okay, so these are acceptable reasons in a proof. So again, the first reason could be the word given, and that's going to be whatever information the statement will be, whatever information was given to you, and then the reason is given. And then following that first statement and that first reason, your next reasons will be either definitions, properties, postulates, or theorems. Now notice what I put on here, previously proven ones. What this means is you can only use information as a reason that I have taught you. So if we're only on chapter 2, you can't give me a reason from chapter 10 because I haven't taught you chapter 10 yet. So whenever you're coming up with your definitions, your properties, your postulates, your theorems, you can only use the stuff I've taught you. So right now we're in chapter 2. So anything from chapter 1 or chapter 2 would be acceptable reasons because we are now in chapter 2. Okay, remember geometry is cumulative. So even when we get to chapter 10, you can use information from chapter 1 or 2 as a reason and a proof once we get to chapter 10. Now also when you're describing your reasons, for example, if you tell me the reason is the definition of vertical angles, you have to specify that you're talking about the definition, okay? Or if you were talking about the vertical angles congruence theorem, then you have to specify that you're referring to the theorem. So if you just put vertical angles and you don't describe which one you're using, you get it wrong. So you have to be very specific in your reasons. So a theorem is a statement that can be proved, okay? You're going to prove theorems using deductive reasoning. So the first theorem, and again, of this chapter is 2.1. Again, we're not going to memorize the number. You're going to memorize the name or what it states. So the first one is called properties of segment congruence. And we can use all of those same properties of equality that we talked about, reflexive, symmetric, and transitive. And then now we can apply them with a congruent symbol. And then theorem 2.2, again, the number is not important. Properties of angle congruence. So all those properties of equality we saw yesterday, we can now say that angles are also we can use the reflexive, symmetric, and transitive property of congruence instead of equality. When it's property of congruence, what'll be in your statement is a congruent symbol. So you'll have the equal sign with the wave. When we were using those POEs, the property of equality, so property of equality, it's going to be an equal sign. Property of congruent, POC, that would have a congruent symbol. But again, if you are identifying reflexive, symmetric, or transitive, I'm okay with you just writing that word. You don't have to include the POE or the POC. Okay, so these are properties of congruence when we apply them to angles and segments. So again, under this column, these are the properties. Over here are the examples of those properties in relation to segments, and over here in relation to the angles. So the reflexive property, remember when we saw it for equality, instead of the congruent symbol here, when it was the property of equality, it was DE equals DE. Now the only thing that's changing is that we now have a congruent symbol in between each one of the things. So symmetric, again, think of the word then as your line of symmetry. And then the FGs match up, the congruent symbols, the DE. And then the same thing for your transitive, sort of like the syllogism. This DE, AB congruent to CD, and CD congruent to EF, the CDs cancel, and then you can conclude that AB is also congruent to EF. And again, it applies to the angles as well. So again, for the reflexive property, angle D congruent to angle D. For the symmetric, again, like the line of symmetry here, and everything matches, or think of it as the order reversing. And then your transitive is where that angle B, the overlap, would cancel, and then you can conclude that angle A is congruent to angle C. All right, so example 1. This is a 2-column proof, and notice the given isn't in the diagram, it's spelled out for you, and they've given us all the statements. So for this one, all we have to do is come up with the reasons. So statement number 1, its reason, nice and easy, it was given to us. So up here, this is the given. And this is always going to be your very first statement, and your reason for that first statement will always be the word given. So when you're doing this on the test, if it's a totally blank proof, do not leave out this first statement and reason. It's worth points. Might be minimal points, but it's worth something. And then the last statement should be what you're trying to prove. The reason is not just proven, it's gonna be one of the properties, definitions, or theorems. So now let's see if we can figure out what they did from step 1 to step 2, or even maybe they just gave us something that they saw in the diagram. So let's take a look and see what they're trying to state here. So they're telling us that AB plus BC is equal to the whole thing. Notice what they just showed us is that if I take 2 little pieces and add them together, it gives me the whole segment length. And this is an example of our segment addition postulate. And you can abbreviate. You could put segment, add, post. So make sure that you tell me that it's a postulate, not that it's a theorem, not that it's a definition. And again, because we use this a lot, if you'd rather just abbreviate it as SAP, that is our segment addition postulate. Next, notice what they've done here is they've taken and they've done a substitution. So notice up at the top, my very first statement, they told me that AC was equal to AB plus AB. So what we can do is we're going to take out AC from the second statement, and we're going to replace it with what AC equals. And then we can, what they did was they put it here. So they took AC and they put it here. And then they took this and they put it here. Your third step could have also been keeping it in the same order, AB plus BC. And then here, instead of having the AC, you could erase that and put what AC equals, which is AB plus AB. But they flipped it around. So this next one is substitution. Because what we did was we took out AC and we put what it equaled from step 1. And then now what they did from step 3 to 4, notice what disappeared on both sides is they subtracted out AB from both sides. So they minused AB from here and from here. And then that's how they ended up with AB equaling BC. And then this last reason would have been the subtraction property of equality. And again, POE. So in the homework tonight, questions 2, 6, and 9 are going to be geometry proofs. Just like last night, even if it's drag and drop, I want to see you make the 2 columns and handwrite those 3 proofs. Also, when you're writing these proofs, if you're writing it all by yourself, you may have extra steps in your proof, and that's okay. As long as your proof flows logically, there's not always just one way to do it, but just make sure it flows logically. All right, let's try example 2. So this time, my given information is that M is the midpoint of AB. So again, I'm going to go ahead and put reason number 1 was given. Now, notice on this problem, we have 2 things that they're expecting us to prove. I won't ever on a test or quiz expect you to have 2 things to prove. So what I might do is maybe on one version of the test, it might have been prove what A had. And then maybe on another version of the test, it might be prove what B has. So I'm never going to ask you to get 2 things that you're going to have to prove in the one proof. It'll just be one thing. But really, for this proof, it's just taking it one step further. Okay, so now, since they gave us that M is the midpoint of AB, that tells me that this segment AM here is going to be congruent to MB because a midpoint splits that segment AB into 2 equal pieces. And that's what they told me in step 2. They told me that AM is congruent to MB, and the reason why they can say that is by using the definition of midpoint. Now, for the next step, all they did was change the congruency symbol to an equal sign. So I'm okay with you not changing it. You could have kept the congruency symbol or just used an equal sign throughout. But if they are giving you a drop down where you're going to change it from an equal sign to a congruence or vice versa, this is going to be the definition. I'm going to abbreviate definition as DEF of congruent segments. So whenever they change from an equal sign to a congruence, this is going to be definition of congruent segments. If you were writing the proof yourself and they didn't have that, you could have skipped this step. The next one, they're showing us how AB was created. So they're going to show that AM plus MB is going to equal the whole thing. So number 4, this is our segment addition postulate. And again, you can abbreviate this as SAP, or you can write it out. Segment addition, I'll abbreviate that, postulate. Then step 5, notice what they did. Since I knew that AM and MB were congruent, all they did was take out MB and they replaced it with what MB equals, which is AM. So they did a substitution here. And now, from 5 to 6, they applied their algebra skills, and all they did was add 1 AM plus 1 AM, and that's how they got the 2 AM. So this one was simplify. You don't want to put addition because the addition is that property of equality. They did not add the same thing to both sides. All they did was simplify. Now you could also say that this is combine like terms. I would also accept that. But on big ideas, it'll be simplify. And then lastly, to go from step 6 to step 7, they divided both sides by 2, and that's how they got step 7. So the division property of equality. If you wanted to say that it was multiplication because they multiplied by the reciprocal, I would also accept multiplication. So the last slide is just writing a 2-column proof. And again, you're going to make one statement at a time until you finally reach the conclusion, which is what you were trying to prove. You're going to be making your statements based on facts, whether you simplify things that was from the step up above, or maybe you bring in a definition or a theorem or a postulate. And again, usually that first statement is always your given information. And again, I'm not going to expect you to pull a given from a picture. I will spell it out and tell you this is what's given. So again, your statements are on the left side, your reasons are on the right. And again, every proof will have a different number of statements and reasons depending on how complicated the question is. At the beginning, when I'm asking you to write your own proof, they're going to be pretty short and basic. If it's a fill-in proof, it might be a little bit longer because it'll have most of it filled in. You'll have to fill in just a few blank lines. And everything must flow logically. Okay, so the questions in the homework, the ones that are going to need work, are going to be numbers 2, 6, and 9. These are proofs. So you're going to write them out. You're going to write them in 2-column format. And then number 7, this one is just show me the calculations. And then the other ones, there's only 10 questions in the homework tonight, so no work will be necessary for numbers 1, 3, 4, 5, 8, and 10.